Welcome student in third session from your textbook, chapter number 13, the magnetic effect of electric current. Today we will continue this chapter. In last session we studied about the magnetic effect of current. Okay, in that we studied the Oersted experiment and second magnetic field pattern produced by current carrying conductor. In that we studied magnetic field pattern due to straight current carrying conductor. So today we are going to discuss magnetic field pattern due to a circular loop carrying current. Clear this one? So आपने पहले ये स्टडी किया था कि when current is passed through a straight wire, a magnetic field is produced around it. Okay. It has been found that magnetic effect of current increases if instead of using a straight wire, the wire is converted into a circular loop. अब wire को आपने किस में converted किया है? Circular loop. So as shown in that figure, a circular loop is fixed to a thin cardboard sheet. उसको आपने किस पे fix किया है? Thin cardboard sheet T. When a current is passed through the circular loop of wire, अब उस circular loop जो wire है उसमें आपने current को pass किया. ओके, मैग्नेटिक फील्ड इज प्रोड्यूस्ड अराउंड इट. तो इसमें क्या होगा? जैसे ही करंट पास करते हैं, ये तो आपको पता है, जैसे ही करंट पास होता है तो मैग्नेटिक फील्ड प्रोड्यूस होती है अराउंड इट. सो द पैटर्न ऑफ मैग्नेटिक फील्ड ड्यू टू करंट कैरिंग सर्कुलर लूप इज शोन इन दैट फिगर. द मैग्नेटिक फील्ड लाइन आर सर्कुलर. कैसी होगी मैग्नेटिक फील्ड लाइन? सर्कुलर. ओके, नियर द करंट कैरिंग लूप. So as we move away, the concentric circle representing magnetic field line become bigger and bigger. मीन जैसे आप दूर होते जाएंगे उस फील्ड एरिया से तो लाइन कैसे होते जाएगी? बिगर एंड बिगर. ओके, एट द सेंटर ऑफ द सर्कुलर लूप द मैग्नेटिक फील्ड लाइन आर स्ट्रेट. और जब सेंटर में आ जाते हैं तो सेंटर में कैसी है मैग्नेटिक फील्ड लाइन? स्ट्रेट है. क्लियर? सो दैट इज सीन पॉइंट M in figure. Okay. So by applying right hand thumb rule, it can be seen that each segment of circular loop carrying current produces magnetic field line in the same direction within the loop. At the center of circular loop, all the magnetic field lines in the same direction, okay, and aid each other. So due to which the strength of magnetic field increases. Clear this one? Magnitude of magnetic field produced by current carrying circular loop at its center. Okay, first directly proportional to the circular loop. Magnetic field जो produce होती है वो so directly proportional to the circular loop. किस पे directly proportional है वो? Circular loop पे. And second, that is inversely proportional to the radius of the circular loop. So in this discussion we have considered the magnetic field produced by a circular loop which consists of only one turn of the wire. So the strength of magnetic field can be increased by taking off circular coil consisting of a number of turns of insulated copper wire closely wound together. Clear this one? Thus, if there is a circular loop having n turns, magnetic field produced by this current carrying circular coil will be n times, okay, as large as that produced by a circular loop of a single turn of wire. So this is because the current of each circular turn of coil flow in the same direction. Means जिस direction में current flow होगा उसी direction में magnetic field भी produced होगी. Clear this one? By each turn of the circular coil then just adds up. So we can say that the strength of magnetic field produced by a circular carrying current is directly proportional to both number of turns and current. Okay, but inversely proportional to its radius R. Thus the strength of magnetic field produced by current carrying circular loop can be increased by increasing the number of turn of the wire in the coil. जैसे आप number of turn coil के increase करोगे तो magnetic field भी increase होंगे. Okay, by increasing the current flowing through the coil and third by decreasing the radius of the coil. और जैसे आप radius decrease करोगे coil का तो मैग्नेटिक फील्ड इंक्रीज होंगी. मीन्स स्ट्रेंथ ऑफ मैग्नेटिक फील्ड इंक्रीज होंगी. क्लियर दिस वन? नाउ नेक्स्ट वन, क्लॉक फेस रूल. ओके, अ करंट कैरिंग सर्कुलर वायर और लूप बिहेव लाइक ए टाइनी डिस्क मैग्नेट whose one face is north pole and the other face is south pole. Clear this one? The polarity north or south means of the two faces of current carrying circular loop circular coil can be determined by using the clock face rule given, that according to clock face rule, look at the one face of circular wire or through which current is passing. So first, if the current around the face of circular wire flow in the clockwise direction, then the face of the circular wire will be south pole. Okay, means जब करंट अराउंड द फेस ऑफ सर्कुलर वायर फ्लो इन द क्लॉकवाइज, जब क्लॉकवाइज डायरेक्शन में फ्लो होगा तो फेस ऑफ द सर्कुलर वायर कैसा होगा, साउथ पोल में. इफ द करंट अराउंड द फेस ऑफ सर्कुलर वायर फ्लो इन द एंटी क्लॉकवाइज डायरेक्शन, देन दैट फेस ऑफ circular wire will be a north pole. Okay, for example, the current in that figure A, the current in a face of a circular wire is flowing in the clockwise direction. So this face of current carrying circular wire will behave as a south magnetic pole. On the other hand, in that figure B, the current in the face of the circular wire is flowing in the anti-clockwise direction of this face of current carrying circular wire will behave as a north magnetic pole. Now remember that if the direction of current in front of face of circular wire is clockwise, then the direction of current is the back face of the circular wire will be anti-clockwise. ठीक है, मीन्स फ्रंट पे अगर करंट फ्लो होगा वायर में तो वो क्लॉकवाइज होगा, अगर बैक फेस पे मीन्स करंट फ्लो होता है तो दैट इज व्हाट circular wire will be anti-clockwise, means that is a vice versa. Third magnetic pattern in that magnetic field due to solenoid. So the solenoid is a long coil containing a large number of closed turns of insulated copper wire, shows in that figure. A solenoid SN whose two ends are connected to a battery B through a switch X. When an electric current is passed, जैसे इलेक्ट्रिक करंट पास होता है थ्रू द सोलेनॉइड, इट प्रोड्यूसेस अ मैग्नेटिक फील्ड. ओके, जैसे करंट पास होगा इन द सोलेनॉइड तो वैसे ही क्या प्रोड्यूस हो जाएगी, मैग्नेटिक फील्ड अराउंड इट. द मैग्नेटिक फील्ड इज प्रोड्यूस्ड बाय करंट कैरिंग सोलेनॉइड इज शोन इन दैट फिगर. मैग्नेटिक फील्ड प्रोड्यूस्ड बाय करंट carrying solenoid is similar to magnetic field produced by a bar magnet. Clear this one? So the lines of magnetic field pass through the solenoid and return to the end as shown in that figure. Clear? So the magnetic field line inside the solenoid are in the form of parallel straight line. This indicates that the strength of magnetic field is same at all points. Strength of magnetic field कैसी है, same है at all points inside the solenoid. Means solenoid में एक जैसी magnetic field है from means beginning to end. Clear this one? If the strength of magnetic field is just the same in a region, it is said to be uniform magnetic field. Okay, तो इसे क्या कहते हैं, uniform magnetic field, because एक जैसा strength है magnetic field का. Clear? So thus the magnetic field is uniform inside a current carrying solenoid. The uniform magnetic field inside the current carrying solenoid has been represented by drawing parallel straight field lines. Even the earth magnetic field at a given place is uniform, which consists of a parallel straight field lines. So the solenoid is a long coil containing a large number of closed turn is insulated copper wire. Okay, so current in each turn of a current carrying solenoid flow in the same direction, due to which the magnetic field produced by each turn of the solenoid adds up, giving a strong magnetic field inside the solenoid. Clear this one? So the strong magnetic field produced inside a current carrying solenoid can be used to magnetize a piece of magnetic material like soft iron. वायर जिसे आपको मैग्नेटाइज करना है तो इसके लिए सोलेनाइड को यूज किया जाता है. मीन्स एक आपने आयरन लिया, सॉफ्ट आयरन लिया, ठीक है, और उसके ऊपर राउंड अप वायर कर दिया. सो उसमें क्या होगा कि जो वायर में जैसे करंट पास करोगे आप वायर में तो उसमें से मैग्नेटिक फील्ड क्रिएट कर देता है आसपास. ठीक है, तो जैसे मैग्नेटिक फील्ड क्रिएट होगी तो जो वो सॉफ्ट आयरन है वो किसमें कंसिडर हो जाएगा, किसमें कन्वर्ट हो जाएगा, मैग्नेट में. तो इसे कहते हैं इलेक्ट्रोमैग्नेट. So the strong magnetic field produced inside a current carrying solenoid can be used to magnetize a piece of magnetic material like soft iron. So when placed inside the solenoid, so the magnet thus formed is called the electromagnet. तो इससे जब मैग्नेट बनाया जाता है तो उसे कहते हैं इलेक्ट्रोमैग्नेट, because with the help of electricity Clear? So a solenoid is used for making electromagnets. So the strength of magnetic field produced by current carrying solenoid depends on first the number of turns in the solenoid, means कितने number of round है, turn है, तो उस पे means डिपेंड करती है मैग्नेटिक स्ट्रेंथ ऑफ मैग्नेटिक फील्ड. लार्ज नंबर ऑफ टर्न इन द सोलेनॉइड, ग्रेटर विल बी द मैग्नेटिज्म प्रोड्यूस. सेकेंड, द स्ट्रेंथ ऑफ करंट इन द सोलेनॉइड, जो द करंट पास थ्रू सोलेनॉइड, स्ट्रॉन्गर विल बी मैग्नेटिक फील्ड प्रोड्यूस. जितना स्ट्रॉन्ग करंट पास होगा इन दैट सोलेनॉइड उतनी ही मैग्नेटिक फील्ड, स्ट्रॉन्गर मैग्नेटिक फील्ड प्रोड्यूस होती है. थर्ड, द नेचर ऑफ कोर मटेरियल, मीन्स उसमें कौन सा मटेरियल यूज किया गया है जिसके ऊपर आपने सोलेनॉइड बनाया है. ठीक है. नेचर ऑफ कोर मटेरियल यूज्ड इन मेकिंग सोलेनॉइड. सो द यूज ऑफ सॉफ्ट आयरन रॉड एज कोर इन ए सोलेनॉइड प्रोड्यूसेस द स्ट्रॉन्गेस्ट मैग्नेटिज्म. क्लियर दिस वन? Next one is electromagnet. An electric current can be used for making temporary magnet known as electromagnet. Means electric current के through temporary magnet जो बनाया जाता है that is called the electromagnet. An electromagnet works on the magnetic effect of current. Let us discuss it in detail. We have just studied that when current is passed through a long coil called solenoid, a magnetic field is produced. It has been found that if a soft iron rod called core is placed inside a solenoid, then the strength of magnetic field becomes very large because the iron core gets magnetized by induction. So this combination of solenoid and a soft iron core is called an electromagnet. Clear this one? So thus an electromagnet is a magnet consisting of a long coil. Okay, means इसमें कैसी रहती है, एक long coil रहती है of insulated copper wire wrapped around a soft iron core. और वो किस पे means wrapped की हुई है, soft iron core में. That is magnetized only when, और ये soft iron core magnetize होगा when electric current is passed through the coil. और जैसे ही आप coil में electric current pass करोगे वैसे ये soft iron core कैसा हो जाएगा, magnetize हो जाएगा. Clear this one? Simple electromagnet is shown in that figure. To make an electromagnet, all that we have to do is to make a rod NS. Okay, NS एक rod है of soft iron. तो NS क्या है, soft rod of iron. Okay, and wind a coil, और उसके ऊपर आपने coil को wrap किया हुआ है. Okay, wind a coil C of insulated copper wire round it. Okay, when the two ends of the copper coil are connected to a battery, an electromagnet is formed. Okay, means जैसे आप वायर के दोनों एंड को बैटरी से कनेक्ट करोगे देन दैट ए करंट इज फ्लो एंड दैट इलेक्ट्रोमैग्नेट इज फॉर्म. It should be noted that the solenoid containing soft iron core in it acts as a magnet only as long as the current is flowing in the solenoid. Means जितना long current उसमें flow होगा उतने उसमें magnetized होगा. Okay, it acts like a magnet. If we switch off the current is a solenoid, it no more behave as a magnet. Means जैसे आप switch off करोगे all the magnetism of the soft iron core disappear as soon as the current in the coil is switched off. जैसे आपने solenoid coil का current को switch off किया then that magnetism of that soft iron core it disappear. Okay, so a very important point to be noted is that it is the iron piece inside the coil which becomes a strong इलेक्ट्रोमैग्नेट ऑन पासिंग द करंट. में जितना आप उसमें कॉइल में करंट पास करोगे उतना ही दैट सॉफ्ट आयरन कोर मैग्नेट क्या होगा, मैग्नेटाइज्ड होगा. क्लियर दिस वन? द कोर ऑफ एन इलेक्ट्रोमैग्नेट मस्ट बी ऑफ सॉफ्ट आयरन बिकॉज सॉफ्ट आयरन लॉसेस ऑल ऑफ इट्स मैग्नेटिज्म व्हेन करंट इन द कॉइल इज स्विच्ड ऑफ. सो ऑन द अदर हैंड, if steel is used for making the core of an electromagnet, the steel does not lose all its magnetism when the current is stopped and it's a permanent magnet. This is why steel is not used for making electromagnet. Electromagnets can be made in different shape and sizes depending on the purpose for which they are to be used. Factors affecting the strength of electromagnet. Clear? So the strength of an electromagnet depends on the number of turns in the coil. Means कितने number of turns coil में. So if we increase the number of turn in the coil, the strength of electromagnet increases. Clear this one? Second, the current flowing in the coil. Means if the current in the coil is increased, the strength of electromagnet increases. Clear this one? Third, the length of air gap between its pole. Clear this one? If we reduce the length of air gap between the poles of an electromagnet, then its strength increases. जितना गैप को आप मीन्स रिड्यूस करोगे उतनी ही उसकी जो स्ट्रेंथ है वो इंक्रीज होंगी इलेक्ट्रोमैग्नेट. फॉर एग्जांपल द एयर गैप बिटवीन द पोल्स ऑफ स्ट्रेट बार टाइप इलेक्ट्रोमैग्नेट इज क्वाइट लार्ज, सो अ बार मैग्नेट इलेक्ट्रोमैग्नेट इज नॉट वेरी स्ट्रांग. ओके, तो ये इतना स्ट्रांग नहीं रहता है. On other hand, the air gap between the poles of U-shaped electromagnet is small, so it is a very strong electromagnet. Clear this one? तो इसलिए यू शेप वाला मैग्नेट जो बहुत ज्यादा स्ट्रांग होता है. इट शुड बी नोटेड दैट इन मेनी रिस्पेक्ट एन इलेक्ट्रोमैग्नेट इज बेटर देन ए परमानेंट मैग्नेट बिकॉज it can produce very strong magnetic fields and its strength can be controlled by varying the number of turns in its coil or by changing the current flowing through coil. Clear this one?